So this is the final result of my project of implementing the Raft algorithm for MicroBit using MicroPython. Here we have a cluster with 4 nodes. Each node has a MicroBit version 2 and a DF robot LED ring. We're going to use these LED rings to show information about each one of the nodes. Each LED will turn on to represent the term in which we are doing the election, or in which term we are using right now in the cluster. Among all the 4 nodes, one will become a leader. When the node is a leader, the LEDs will be green. When they are follower, the LEDs will be blue. And when the node does not detect a leader, it will try election. And then when it's trying election, it will become red. After a leader is chosen, then the leader can change the counter. So in the center here, in the LEDs, we are going to see a counter of numbers. It's an integer counter. When we press B, we increase that counter. When we press A, we decrease that counter. And then each one of the nodes will replicate the same amount. Only the leader can change the counter, and the followers can only show what the counter currently is. So I will now turn on the cluster. They will start the election to see which one is the leader, and after a leader is chosen, it will become green, and then we can see the counter working. So I'll turn them on. They are turning on. We can see that some are red and some are blue. So blue are trying to become followers and red are trying to election. They are raising up as a candidate to be the leader. The election is happening. They will eventually decide which one of them is the leader of the cluster. Yeah, they finally decide that this one is the leader. So the color of the LEDs are green. So this one is the leader. The others have blue color on the LED. And we can see that it took a long time, so many terms, to actually decide which one of them would be the leader of the cluster. Now in the center we can see that there is the number 0. So this represents the current value of the cluster. If I go to a follower, any one of them, and try to change, pressing the B or the A, nothing happens because they are the followers, so they should not be able to change the amount. If I go to the leader and then I press B, it should increase to 1. And the number 1 will be replicated to all other nodes. So each one of them also have the same number 1. If I increase again, it should go to 2, and then all nodes should have the number 2. If I decrease, all counters should go back to 1. If I increase multiple times, they all should have the same number. Right now it's number 4. If the leader turns off by any reason or lost communication with the followers, then the followers will notice that, and then we start a new election. So to test that out, I'll turn off the leader. Yeah, now this one, start the election, it become quickly red, and now it become the leader. So now this one is the leader. If I press A, should go to 5 here, and now the others should also have 5. I press A, should go to 4, all the others should go back to 4. Now let's assume that that node that turned off turns back on. It will restart, we will try to find a leader, and if it finds one, we'll just get the current value of the cluster. So if I turn it on, it just immediately become blue and the counter 4. So it just become a follower of this one here. So this now is the leader of the cluster, and all the changes done here will be replicated to the others.